Hello friends, welcome to series of basic chemical process engineering calculations. Today we'll start with the basic calculations for line sizing for the utilities or liquids like cooling water, chilled water, process water or any liquid. So basically line sizing is done with the simple formula which is Q is equal to V into area where is Q is the volumetric flow rate. V is the velocity of liquid and A is the area of that pipe. Also, there is another alternative method. With that, we can also calculate the line size. That is depend on the pressure drop. For now, we are moving ahead with the line sizing calculation with reference to the velocity. For that, we will consider one of the example. For that, we consider the flow rate of liquid is 15 meter cube per hour. Density of that liquid is 1000 kg per meter cube. Then we select the area of the pipe is calculated like uh, based on the for the cylinder pi by 4 into d square. D is the diameter of the pipe which we are going to calculate. Here V is the velocity of the fluid. For here we are considering the fluid as a cooling water. So we can consider the velocity in between 1.5 meter per second to 3 meter per second. And for more details, you can take a reference of velocity from the API 14E guidelines. For here, we are considering the velocity 2.5 meter per second. Okay, you can select uh, 3 also. Or somewhere you can select optimum velocity is 2 meter per second, and velocity is directly proportional to the area of or diameter of the pipe. Okay, for here for calculation we are considering 2.5 meter per second. Then we have known parameters is the flow rate, another parameter is the velocity, though unknown parameter is the diameter of pipe. Okay, so we have to calculate the D. First we okay, so calculate the diameter of pipe. We check. We first convert that velocity into meter per hour. Okay, meter per hour. Okay, to calculate diameter, we need to check equal to square root of flow rate into flow rate divided by area of pipe, which is pi by. To calculate diameter, we have to divide the flow rate Q divided by V and area. Okay, divide by pi by 4 into the velocity. We will get the diameter of 5 in meter. Okay, we can we can convert that length with simply multiply by 1000 into mm. That means key are calculated line size for 15 meter cube per hour flow rate is 46 mm, we can consider it as a 50 mm round of, as this is standard of the piping. In similar way, you can check for the different flow rate and the different fluids. So we will just write down some recommended velocities for the fluids. Recommended velocities for fluids. With the help of that velocity, you can calculate the line size from the above reference calculation. For solvents, keep velocity below 1.5 meter per second to avoid the friction and the static charge generation. If we high pressure steam, you have to consider 35 to 40 meter per second. Okay. For low pressure steam, consider 15 meter per second, and medium pressure steam considered 25 to 30 meter per second. High pressure in the sense 10 bar G. I will write here, otherwise you guys can get confused. 6 to 7 bar G, and low pressure means below 3.5 bar G. Okay. Low pressure here you can consider 10 to 15 meter per second, and for high pressure air, high pressure air you can consider 20 to 25 meter per second. Here 10 to 15. Okay. I hope you get the clarity about the how to select the line sizing based on the velocity. In next series, we will try to cover some basic example of the line sizing calculation for particular reactor.